Unit, word or group of symbol which represent the quantity uniquely is called unit. Example, mass as kilogram or gram. For example, if there is some salt, like salt here, you won't say there is some salt or there is a large amount of salt. You would say there is 15 gram of salt or 5 kg of salt. So the kg or gram, these are called units. Basically something with which we can measure or like call out a n quantity. What is quantity? Anything that we can measure, like 5 pens, 5 pen, 5 pen, anything we can measure. Fundamental units have two types: fundamental units and derived units. Fundamental units, units which are assumed and cannot be derived, are called fundamental units. All other units are derived from fundamental units. We only have 7 fundamental units. Okay, everything we have is derived from these fundamental units. What are the fundamental units? Length, mass, time, electric current, temperature. We only have these 5. And what are the SI units of them? SI, standard. What was the full form? I forgot. Standard something something. Okay, but yeah, SI units. Basically, it's a system which is used all over the world, like base common system. Meter, kilogram, second, ampere, Kelvin. These are the basic, like fundamental, at the most basic level. You cannot further break it down. Length, mass, time, electric current, and temperature. The amount of substance, mole, and luminous intensity. These two are there, but like in 11th, they won't be applicable for you right now. So you don't need to do it right now. So units have actually two parts: fundamental units and derived unit. We just read fundamental units, and what are derived units? Units which are not fundamental and derived from the fundamental units are called derived units. Yeah, basically it's just that. For example, force is Newton. What was the formula of force? I forgot. Yeah, mass into acceleration. Yeah, so basically force is made up of mass into acceleration, which is uh, like acceleration is to the, what's that acceleration? Change in velocity upon time. So yeah, force is derived. It's made up of mass and other entities of from this fundamental unit. So it is a derived unit. Anything which is made up of the fundamental units, it's derived unit. Basically, you don't have to learn many things. There are only 7 units, 7 fundamental units. So anything outside of the 7 fundamental units is a derived unit. You have to assume that. Measurement, it's a process of determining how large or small a physical quantity is as compared to a basic reference quantity of the same kind. Measurement is a numerical value times unit. uh, I mean, I don't think I have to explain this, but still, it is a process. Like how will you even know how much big or small a unit is without a thing is? Like, we have to measure this pen to know. Basically, that's measurement, something like that. In measurement of a n represent the numerical value, and u represent the units. For example, 15 kg. 15 is our numerical value and kg is our unit. That's simple. Okay, dimensions. Basically, this is all about dimensions. So every fundamental units or derived fundamental unit have a dimension. Like, but representation of any fundamental or derived unit is a form of certain symbol allotted to each fundamental unit is called dimensional formula, and the certain symbol is called basically dimensions are something to represent the fundamental unit. Yeah, they do have as a unit, but these are just units. We need dimension to represent a fundamental unit. It would make it more unique. And a quantity can have different units. For example, length have meter, kilometer, and what not. But length only have one dimension, that is L. Same goes for current, time, mass, amount of substance, luminous intensity, temperature. These are the dimensions. You have to learn it. Yeah, might sound like bit confusing up till now, but hear me out, guys. For example, we have to basically this chapter will only majorly ask you to derive a dimensional formula. For example, they will ask you to derive a dimensional formula of speed. Now speed equals distance upon time. Okay, fuck. So what is distance? You travel from this point to this point, like distance. What are you covering? You're covering a length. And what is length? Length is a fundamental unit. So fundamental unit have a unique dimension which is L. So you can say L. Time. What is time? Time itself is a fundamental unit and it got a unique dimension. So you can say upon t. So when the t goes up, like you cannot write it in this form. You can't write it in fraction form. You have to write it like let t minus 1. That's basically t inverse. You can say t minus 1 is like preferred way of saying. Like this easy. It's just that easy. For example, we let's go to a bit you know tougher one. Force, favorite one. Mass, okay, into acceleration. Now mass, of course, mass. What is mass? I mean, like that's kind of basic. I mean, mass is a fundamental unit, so we don't have to go all the way to describe it. And mass have a fundamental unit called mass has a mass have a dimension, unique dimension at that. We will just write it m. And what is acceleration now? Like acceleration is a derived unit itself. Acceleration is a derived this one unit itself. So we have to first break it down. So what is acceleration? Acceleration equals change in velocity. Okay, my paper is short, never mind. Upon time. Oh damn. So now we have to calculate velocity too. What is velocity? Velocity is distance upon time, basically lt minus 1. Change in velocity or velocity is almost the same thing. I mean, is the same thing. So you can just type like change in velocity upon time. So acceleration equals to change in velocity upon time equals to lt minus 1. We are getting this value from here. Distance velocity equals to distance upon time lt minus 1, and upon time equals to t. So when this t will go up, it will become lt minus 2. Yeah, it's adding up. Okay, so here it will come lt minus 2, and now we will multiply it. Basically m lt minus 2. Since there is no value of here like 1 0, you don't have to write anything. And if it's not given, you don't need to add it. Like here distance upon time, mass is not given, you don't have to add it. It's just simple as that. How to derive, really that simple, nothing else. It's just that. And you gotta learn all the errors, and there is a small topic of error counting. I would prefer you watch a proper lecture on it.